Alright, so here we are with Chapter 5, number 26, and it goes, a 4,000 kilogram truck is parked on a 15-degree slope. How big is the friction force on the truck? So as you can see, I've already drawn the free body diagram. I've tilted my axis now because we're on a hill. And we can see that we've got the normal force moving perpendicular to the surface. We've got our weight going straight down, and our frictional force, the static kind, is moving up the hill to balance out so that the truck doesn't move. Like we've talked about a million times in class, this would be a good free body diagram for AP if they ask you to draw a free body diagram on the test. But if we want to solve the problem, we need to do a little bit more work. So what I'm going to do is I'm going to draw my components for the weight here. So I've got W sub x, and I've got W sub y here to fill those in. So that's going to help me. And I can get rid of that W because now I have its components, which make life a lot nicer. So just writing down a little bits that I know that the mass of the truck is going to be 4,000 kilograms. And they're asking us to find what is the frictional force being applied on this truck so it doesn't fall. So if I look in the x direction, I see that the frictional force is there, so that's where I'm going to start. I always like to pick a place where I think it might get me the answer quickly, or it seems like the obvious, most direct place, and if it doesn't work there, then I'll find another spot to go in. But because it looks like, frictional force is in the x direction, it's a good place to start. So writing what I know, I've got the weight in the positive direction, I've got the friction force in the negative direction, and that's equal to ma sub x. Now, it's stopped, so there's no acceleration, so we can call that 0. So it just becomes then the frictional force is equal to the weight and the x component of the weight. So then we have mg times the sine of theta. Plugging in what I know that the mass of the truck is 4,000 kilograms. Gravity's 10, and then we get the sine of 15. Remember from class, we did that quick little problem where we see that when we tilt the axis now, the x component gets the sine because it's the opposite side of our triangle. So solving for all of these, multiplying them together, doing that quick little trig function, we should find that the the frictional force for this is equal to 10,353 newtons.